today's chemistry class. Today we will discuss the remaining electrophilic substitution reaction of amines. Today we will see nitration reactions. Nitration of aniline. Aniline can be nitrated to para and ortho products, but direct nitration leads to the formation of tarry oxidation products. That is why we protect the NH2 group and we discuss the nitration here. Clear? So, nitration of aniline. Aniline is benzene ring with NH2 group. First, this aniline can be the NH2 group. First we protect and we convert aniline to acetanilide on reaction with acetic anhydride. That means CH3 CO twice O is acetic anhydride. So you get this compound benzene ring NH CO CH3. This is acetanilide. Tanilide. And this one is aniline. So aniline can be converted to acetanilide on reaction with the acetic anhydride. To protect the NH2 group, we convert it to acetanilide. Then this acetanilide on nitration, that means reaction with the nitrating mist, that is concentrated HNO3 and concentrated sulfuric acid. Acetanilide on reaction with nitrating mixture, that is concentrated nitric acid and concentrated sulfuric acid. You get orthonitroacetanilide and para-nitroacetanilide. Acetanilide NHCO orthonitroacetanilide plus para-nitroacetanilide. This is ortho product. This is para product. This is orthonitroacetanilide. This is para-nitroacetanilide. Then this ortho and para-nitroacetanilide on hydrolysis. You get the desired products. That is orthonitroaniline NH2 NO2 plus para-nitroaniline. These are the products of nitration. So first aniline on reaction with acetic anhydride, you get acetanilide, which on reaction with the concentrated nitric acid and sulfuric acid, you get ortho and para-nitroacetanilide. These compounds on hydrolysis, you get orthonitroaniline and para-nitroaniline. That is all about nitration. Clear? Next, we will see the reaction of aniline with sulfonation reaction. The next reaction is sulfonation. Sulfonation reaction. As we will discuss sulfonation. Sulfonation is nothing but a reaction with a fuming sulfuric acid. When aniline is on reaction with fuming sulfuric acid, you get para-amino benzene sulfonic acid. That means aniline on reaction with fuming sulfuric acid, you get para-amino benzene sulfonic acid, or it is also known as sulfonic acid. So aniline on reaction with fuming H2SO4. It means very concentrated sulfuric acid. Fuming H2SO4, you get para-amino benzene sulfonic acid. That means SO3H attached at the para position. It is known as para-amino benzene sulfonic acid. Para-amino benzene sulfonic acid. Para-amino benzene sulfonic acid, or it is also known as sulfanilic acid. Sulfanilic acid. That is the reaction of sulfonation. That is sulfonation reaction of aniline. And this sulfanilic acid or para-amino benzene sulfonic acid has a property. It exists as sweeter ion. It exists as sweeter ion. So here you can see that para-amino benzene sulfonic acid, it exists as sweeter ion. Okay, that means here para-amino benzene sulfonic acid, SO3H NH2. This is our para-amino benzene sulfonic acid. It exists as sweeter ion. So here this H will go from SO3H and here it forms NH3 plus and it becomes SO3 minus. That means this H is shifted from here. That means it shifted as H plus to NH2 and it becomes NH3 plus and here it forms SO3 minus. You can see this. This is NH3 plus and this one becomes SO3 minus. It is known as sweeter ion. Sweeter ion means it is a bipolar ion. Bipolar ion. Sweeter ion means bipolar ion. That means both positive and negative charges are there. Both positive and negative charges are there. Clear? That is known as sweeter ion or it is known as bipolar ion. Here we have both acidic SO3H group and basic NH2 group. So these are H plus from acidic SO3H is shifted to basic NH2 and you get NH3 plus and SO3 minus. And it is known as sweeter ion. Sweeter ion means it is a bipolar ion. Bipolar means two poles, both positive and negative charges are in a compound. That is known as sweeter ion. In the case of amino acid also, sweeter ions are possible. Clear? That is all about the sulfonation reaction. So by sulfonation reaction, you get para-amino benzene sulfonic acid or sulfanilic acid. And this sulfanilic acid exists as sweeter ion or bipolar ion. That is all about sulfonation. Next we will see what happens when aniline on reaction with can it undergo Friedel-Crafts reaction. Actually aniline does not undergo Friedel-Crafts reaction. Aniline does not undergo Friedel-Crafts reaction. Aniline does not undergo Friedel-Crafts reaction. Friedel-Crafts reaction. Aniline does not undergo Friedel-Crafts reaction because on reaction with aniline, the catalyst used in Friedel-Crafts reaction, that is AlCl3, which forms salts with this aniline. So the reaction is not possible. That is why aniline does not undergo Friedel-Crafts reaction because aniline forms salts with AlCl3, that is aluminium chloride. So because of that, the nitrogen atom on aniline gets a positive charge and it acts as a deactivating group. So it is a very important point. Aniline does not undergo Friedel-Crafts reaction. Why? That is a repeated question in CBSE question paper. And the reason and the answer is, it is because aniline forms salt with AlCl3. AlCl3. That is a Lewis acid used in Friedel-Crafts reaction. Clear? That is all about electrophilic substitution reactions of aniline. Clear? Okay. Now we are moving on to the next topic, that is diazonium salts. Next topic, that is diazonium salts. The next topic is diazonium salts. So let us see what is diazonium salt. What are diazonium salts? Di means two. Here di means two and azote means nitrogen. So two nitrogen atoms are there in this benzene diazonium salt, and one halogen atom will be there, and when benzene ring is also there. So this is the formula, that is benzene ring, then N2 plus X minus. This is our diazonium salt. This is benzene diazonium salt. Clear? This X may be ClBrF, and usually we discuss X is Cl. Instead of X, here we have chlorine. So here we discuss the compound benzene diazonium chloride. That means, or generally we can write Ar N2 plus X minus. This is our benzene diazonium chloride. Ar N2 plus X minus. Are you getting me? Clear? So let us discuss on this di for two nitrogen at 2, and azote means nitrogen, and onium came from ammonium. Salt. So it is diazonium salt, and benzene, our example is benzene diazonium chloride. That is Ar N2 plus Cl minus. Ar N2 plus Cl minus is our very familiar compound. The preparation we have already discussed, or we have already studied in reaction of amines. That means amines on reaction with NaNO2 and HCl at 0 to 5 degrees Celsius, you get benzene diazonium chloride. In properties of aniline, you have already studied this preparation of this compound. Clear? So let us see what are the how can we prepare. Already we discussed it. Once again we can see. It is known as diazotization reaction. Diazotization reaction. Diazotization reaction. Diazotization. That means aniline on reaction with sodium nitrate and HCl at 0 to 5 degrees Celsius, you get benzene diazonium chloride. So we can discuss that. That means aniline, that is benzene ring with NH2. Benzene ring with NH2 on reaction with NaNO2, that is sodium nitrite, with in presence of HCl at 0 to 5 degree Celsius, you get benzene diazonium chloride. That is ArN2 plus Cl minus. This reaction is known as diazotization reaction. Along with you get NaCl and H2O. NaCl and H2O. This is our reaction. This is our diazotization reaction. That means aniline on reaction with sodium nitrate and HCl at 0 to 5 degrees Celsius, benzene diazonium chloride is formed. This is known as diazotization reaction. Clear? That means ice cold solution of aniline, ice cold, that means 0 to 5 degrees Celsius, ice cold solution of aniline in HCl on reaction with sodium nitrite solution, you will get benzene diazonium chloride. That is all about preparation of benzene diazonium chloride. The reactions and the properties, physical as well as chemical properties, we can discuss in next class. So that is all about today's class. Today's class we have seen nitration of aniline and sulfonation. Then we have discussed what is diazonium salt, how can you prepare diazonium salt, what is diazotization reaction. The main question is, today's main important point is why aniline does not undergo Frey-Graf's reaction, because aniline forms salts with aluminum chloride and aniline, nitrogen gets a positive charge and it acts as a deactivating group. That is the reason. So that is all about today's session. Thank you.